Okay, everybody, I guess I'm back. I'm gonna have to maybe have a more exciting voice or have some intro or something when I start to film these, but we're kind of done, I think, covering everything with the power chassis and ready to move on to actually testing some of the power boards. So we're gonna have to actually connect our cable here, our power cable from our power chassis to our power board, which will be up here. But what I first figured I would do is just cover a few things that I learned about these power boards. And this power board is the A082-90412, and this is revision D. And sorry about the shadows there. I'm trying to put as much light on this work area as possible, so hopefully it makes it a little bit better. So this is a D version board. And over here I actually have one that is a C version. Let's see if you can see that. So 90412C00. And what, from reading the forums on KLOV, KLOV, and also reading, obviously, there's a few differences between these two boards that I can figure out. And I'll turn them sideways here. The first one is on the C version of the board. There's a resistor called, I think it's called R300, and that is tied to this capacitor. Let's see, what's the capacitor number there? C106, I think, is the capacitor number. But you see this resistor tied between this capacitor, and this capacitor is for the 5-volt line. This resistor, I guess, according to, I think his name's Ed Lutz, E. Lutz on KLOV, was to put a load on the 5-volt line, so when you tested it, when it wasn't plugged into the game, when you tested the 5 volts, it would actually be regulated correctly and not read high. So they added this resistor 300 there to the C version boards, maybe even to the B and A. I don't know, I don't have any A or B version boards, but it's definitely on the C version of the board. And the other thing you see is, let's see if I can zoom in here, R219, 218, U6, those R211, I guess. I don't even know if that's populated on the other board, but there's some resistors, and specifically U6 and R219 and R218 that are not populated on this board. And I think this is part of a circuit that's called the async. I made a post about this or something on the forums, but this circuit is not used in a bunch of games. I think it might only be used in Discs of Tron or the environmental Discs of Tron or something like that. I don't know. It's called the AC sync circuit. So AC Alpha Charlie sync circuit. And it's not used, obviously. It's not on this board, rev.C. This rev.D board actually came out of my Spy Hunter. This is the actual board that came out of my Spy Hunter. And it still actually has the original battery on here. A lot of times these boards, these batteries, because they're left on, causes corrosion and starts to eat up the components down here, these diodes of the battery circuit, as well as this connector. But this one actually has not leaked, which is kind of cool. This one over here I actually did leak, and I cleaned it up and removed the battery and kind of sanded down some of the traces and stuff to get the corrosion off, treated it with vinegar, etc. So anyway, sorry, running on a little bit, but back to the differences between the rev.D and rev.C. So you can see on this rev.D board that the AC sync circuit components are populated. So you have a U6 here, a R219, it's kind of hard, R219, R218, etc. And these are, this U6 chip actually needs 5 volts, I think, to work. This, I'm kind of guessing a little bit. It's educated guess, I guess. And so it's coming off of the 5-volt line, being fed via this resistor to the U6 chip. So that's why the R300 resistor is not tied onto this C106 capacitor on this board, rev.D. is because the components for the AC sync lines are there, and those components put enough load on the 5-volt line where it tests. You're able to test it fine when not plugged into the game PCB. So anyway, I'll pause for a quick second so I can okay, hopefully this is a decent angle here. So a few more things, I guess. Also, I didn't touch on this, but C207 and 208 are also part of that AC sync circuit, including U6, R219, and I think R218. But anyway, that's enough of the async circuit. It is there on rev.D board, and it's not there on rev.C or probably below that. So you can see I labeled a few components on this board to kind of give you an idea of what components go with what, starting with the heatsink and the transistors that are on this heatsink. Q104 and Q103 are part of the 5-volt regulated circuit. So as we talked about the 8-volt unregulated, we were measuring 10 volts, I think, coming from our power chassis. But eventually, I'm not going to go through the whole circuit, but eventually it comes to these components here. And you can actually measure the unregulated voltage from the collector side, which is the piece of metal here on the top of this transistor is the collector of the transistor, and that should measure around 8 volts unregulated when going to ground. The other Q101 transistor is actually for the 12-volt regulated circuit, so you can measure at the collector side just by putting a lead here, and I'll demonstrate all that, the 15-volt side. You have kind of, three, there's a lot of different components and sections to the board, but there's a few main ones. First, it's supposed to provide take the unregulated 5 volts from the power chassis and the game transformer over here, and basically make that regulated on this board. So that is done via C106 and I believe R10, Q103, etc. There's a component. The diagrams show you what components are part of that 5-volt regulated circuit. Then you have the plus 12-volt regulated circuit, and that's where this capacitor comes in. That's why you can see a test point that I marked here on this. What capacitor is that? C102. Yeah, it's kind of hard to see, but C102 right here, you test for your 12-volt, and that's part of the 12-volt regulated circuit. And you have your adjustment knobs for those two. And then on the far right here, you actually have your rectifier diodes, I guess. I guess these are in a form, I used the wrong term, so this is like a diode bridge or something. So, it's using all 4 of these AC powers coming in, and that's our isolated 12-volt from we talked about on the power chassis, comes into this rectifier, these 4 rectifiers here, D101 through 104, to create 12-volt unregulated voltage for the audio circuit. That is then filtered by this 4700 capacitor C101 before it goes to your amplifier boards inside the game. Now, a couple things that are probably worth mentioning here is that the negative or the common side to this unregulated 12-volt, isolated unregulated 12-volt, is not tied to the other grounds for the 12 volts and 5 volt, which are regulated. So they're coming from 2 different transformers. They have 2 different comms. But there is a jumper that can tie them, those common or logic ground, or whatever you want to call it, tie those together, and that's this jumper JW4. Now you can see that it's cut. Almost every power supply I've looked at, this is cut. So the unregulated, isolated 12-volt ground is not tied to the regulated 12-volt ground. And that's probably by design. I'm not an electrical engineer, so I don't know why that is, but I just wanted to mention that this JW4 is what would tie those together. There is a sense circuit on these boards. I don't know. I don't believe it's actually used by any MCR games, or maybe it is. Correct me if you're watching this, and feel free. What these jumpers do, JW1 and JW1, if you can see down here, basically ties the common side of the regulated voltage, or the ground, logic ground, or whatever you want to call it, to the sense return line from the game PCB if it was plugged in. So that's what kind of doesn't make sense to me. So I mean, it ties basically the sense and the ground together. I don't know if that's actually bypassing the sense control, but I don't know. It's something that's interesting to me. On every single game, it's there. So it ties the sense return, the ground sense return from the game PCBs. JW1's for the 12 volt return, which is almost never used. JW3 is, I think, for the +5. Am I right? And then JW2 basically ties the +5 volt sense lines and the +12 volt sense lines together. So they, I guess, in certain games that were like 12 volt bandwidth hog, regulated 12 volt bandwidth voltage hogs, you could disconnect this so that the sense lines, the 5 volt and 12 volt sense lines, were not tied together. But basically, in all the three power supplies I've looked at, this JW2 is there, which ties the 12 volt and 5 volt sense lines together, circuits together. So anyway, I think that's JW3. Let me see. If there was anything else. I think that's pretty much it. But just quick review. JW1 ties the 12 volt, I believe, sense to common, or maybe it's the 5 volt, I'm not sure. JW3 ties the other sense line to the common, and JW2 ties both 5 and 12 volt sense lines together. So that's what those jumpers are doing. And from a test point standpoint, just have a few test points we're going to put for our unregulated isolated 12 volts. We're going to put ground on this side of the capacitor, +12 over there, to measure our 12 volt regulated. We can use any common ground connection. I think most people use this one over here off of C106. And then the 12 volt, you'd go to the plus side of this capacitor, C102. And then for the 5 volt, we measure over here, plus side on this side of the capacitor, and ground over there. And then lastly, there is a battery connection where you can measure how much voltage is going to the battery. When the game is powered up, that should be 5 volts, or plus, a little bit more than 5 volts. And when the game is powered off, if you have a rechargeable battery in here, it should be around 3 volts, or 3.6 or something like that, is what these batteries were. So I'm actually going to put the battery mod in here and use a coin cell battery instead, but I will show you how to test these test points real quick, and obviously adjust the voltage. This one here is for the 5 volts adjustment. What is that? VR102, and VR101 is for the 12 volt adjustment. Another thing you want to check is this fuse here. This F1, I think it says, is supposed to be a 3/8 amp fuse. Sometimes it's upgraded to a 1/2 amp fuse, slow blow, 250 volt. I don't know. It has something to do with, it should be it should blow fast if there's a problem on the power supply. I'm not able to articulate it quite well, but both of the boards I checked actually had 10 amp fuses and 5 amp fuses in here, and you definitely want to make sure that this fuse is low enough that it will blow, because I think it's tied to the ground, and if voltage is coming back, you want it to blow before it ruins some components on the board. So definitely double check this fuse F1 and make sure it has the right voltage and amps rating. So 3/8 amp, I think, by default, and I think in later power supplies they did increase that to a 1/2 amp. The other thing they did increase, I didn't talk about this on the fuses, but on the power chassis over here, you can I film it good? I don't. The 12 volts lines usually have 4 amps, and this is before it's regulated. Sorry about that, you can't really see it. And the 5 volt lines usually have 5 amps. Now these were also increased over time by Midway, where I guess the game PCB started drawing more and more power. They had to keep increasing the amps on here. So you'll find anywhere from 3 amp fuses, 2 amp fuses, to 5 amp fuses. But I think for the most part, the 12 volt lines in the latest revisions used 4 amp fuses. The 5 volt lines used 5 amp fuses at the max. So that's all I have right there. So okay, I figured well, before we test these connectors here and start testing voltage and stuff, I'll just cover these pinouts here. This looks like it's upside down, obviously, but from a pin standpoint, this is J5 connector, and you can see that's male there. The one that goes into the cabinet that plugs into the PCBs would be female, obviously, and J4 is female on this board, and it would be male on the connectors going into the cabinets. You count the pins, you can see it's pin 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So anyway, these are what go to distribute the regulated and unregulated power to the cabinet. So there's another circuit that I didn't mention on this board is the reset circuit, and that is very important. A lot of people that have the switcher end up having trouble with the reset circuit, and I do not, off the top of my head, know which components that's a part of. One thing to mention though is this U3 chip. It's a voltage regulator, I believe. Pretty much touches every voltage through this board, like 12 volts, 5 volts. Almost every line comes back to this circuit of this chip somehow. So obviously it's very important to this board as far as doing what it's supposed to do. So what I did, and I'll take a picture of this too, is kind of mark up the J4 and J5 connectors and what they're used for. So you can see down here, I'll kind of zoom in a little bit, pin 1 is for the battery. So when the PCB first boots up, it's checking to something on this line, because this connection goes to the CPU board, I believe, to see if it's functioning or has voltage on it or something before it actually boots up. So that's actually pretty important. Actually, I'll stop. I'll back up a little bit. So just how I marked up this diagram here of the connector is everything that has a dot on it is what my Spy Hunter is using. So if you don't see a dot on the pin, that means that it's not actually being used in the Spy Hunter cabinet. And that could apply to other games as well, but this is specific to Spy Hunter here. And then I drew dotted lines around the common connectors that are connected to each other or have the same function, if you will. So that's what you're seeing there as far as colors go. So and then I would try to say what they were for. So pin 1 is for battery, pin 2 is for the 5 volt sense return from the PCB, and that's not even connected on the Spy Hunter. So like again, I said, is like I'm not sure if any of the MCR games actually use the sense circuit that's built in, but somebody's probably going to correct me or educate me on that. Pins 3, 5, and 6 are all your positive side for your 5 volt regulated. Pins 4 and 7, this is on J4 connector. Pins 4 and 7 are your 12 volt common, so that or negative. is where you would put your negative lead on for testing. Pins 8, 9, and 10 are your +5 common. And just so you, on this board, I talked about the jumpers. The 12 volt common and the 5 volt common are tied together because the sense lines are tied to the common, and 12 volt and 5 volt sense lines are tied together. So those are all actually tied together. 12 volt pins 11 and 12 are for your +12. I didn't have a better color marker there, so I marked it with green. And then pin 15 is your reset circuit. So off the top of my head, I can't remember if it's keeping it high or holding it low or something until it has enough power, until the power board has a 5 volt stable. So it's either, it has something to do with that, but it definitely is. The CPU board is relying on that reset pin before it can boot the CPU. And then on the J5 connector, we'll start from the bottom. Pin 1 is for your coin counter, I believe, voltage. It is the unregulated 8 volts that's coming from the 5 volt line, I believe. So this is the unregulated, yeah. But it's before it gets regulated on the power board. So this is coming straight from the game transformer, I believe. Pins 2 and 4 is your 5 volt regulated. So obviously after it goes through this capacitor that we talked about before, 5, 3, 5, 7, and 8 are all your common or negative for your 5 volt line. Pin 6 is your 12 volt sense line return, and again, that's not connected. And as they mentioned, I think in the documentation for MCR games, I don't know if any MCR games actually used a separate 12 volt sense line, so it's very uncommon probably that would be connected. Your pin 9 on J5 is also for 12 volt regulated, and pin 12 is 12 volt common. Pins 11 and 15 is really your unregulated, isolated 12 volts coming from the isolation transformer, and then it goes through, well, it's not going through the capacitor obviously, but it's tied to this negative side here of the big capacitor, C101. And then you have, and you can see that only pin 15 is actually connected on Spy Hunter. And then J5 pin 13 is your unregulated 12 volt isolated, but it is filtered, goes through that 47, goes through this capacitor C101, and it's for your audio circuit. So this goes to your, should go to your power amplifier board, power board, or whatever it's called. The other voltage is unregulated. It's called on the schematics auxiliary voltage, and this is also isolated. It's comes from the same line as pin 13, except for it's not filtered. So it goes, just kind of should be around 12 volts unregulated, so it could be upwards of 16 volts, and it says it's for control lamps. I don't know what game uses it, but it's not used in Spy Hunter. So I'm going to take a picture of this too, but just to kind of, if anybody wants to do a screenshot, I'll pause for a second. And then next we will test the board. I have the power board plugged into the transformer over here, and just going to quickly show the test points, etc. So hopefully you guys can see this somewhat decently. I don't know how hard if you can actually see that, but all right, here we go. I'm just gonna, just because it's a little bit easier with this. Well, normally you come in with this your ground connection here. I have my meter set to DC volts, and for the 5 volts, we're gonna go with this first capacitor, which is C106, and we go to the positive side there, and we have 5.06 volts. So hopefully you can see that and it looks normal. And we can adjust that here with this. So if we want to, this is a VR102. If we want to turn that up some, we can see that's 5.15. So adjust it down, try to get it to about 5.05. With no PCBs connected, but again, because we have that AC sync circuit in there, it is putting a load on it, so you know, somewhat of a load. But we'll have to measure it at the chips on the power board to be sure. But there's 5.04. Now, leaving our negative lead on the same location, we come to C102 to measure our 12 volts. That's good. VR101 here is our 12 volt adjustment, and we can also measure our battery voltage right here, and we see that that's 5.4 volts. We could also measure the same location here. So 5.4 volts is actually going to the battery right now. If I powered it off and measured the battery, we should see about 3 volts. So let's go ahead and do that real quick. Come to the same location, and we're seeing about 1.5 volts. We should see about 3. And if I just measure it, the battery, so the battery has about 1.5 volts. So it might actually be charging. This battery, despite being 30 plus years old, probably is still charging, because I did that earlier and it was only putting out like half a volt. So we'll power back up. And now what we want to do is check our 12 volt unregulated. So to do that, we have to actually, it won't work if I come to this ground. We have to go to this ground for the isolated 12 volt. And we're seeing 16 volts DC. So this is unregulated, isolated 12 volts that goes to the audio circuit, and it's 16 volts right here, because it is unregulated. Let's see if there's another voltage area I can measure. The other thing, let me just see what it looks like if I try to use this other common. Yeah, so you'll get an incorrect reading if you use the normal regulated 5 volt or 12 volt common and try to measure this. It won't work. You have to come to the common for the isolated 12 volt circuit. Okay, so the other thing I wanted to show was how you could actually just come straight to the collector side of these transistors to measure the unregulated voltage. So this is the 12 volt unregulated that does get regulated. It's getting 18 volts DC. That's coming from the game transformer on the power chassis. And for the 5 volts, it's 10. So that matches what we were seeing over on the power chassis when we measured it there as well. So I think that's kind of measuring it that way. So let me break out the ESR meter and let's check out these caps. So obviously I've now powered it, the power board off, excuse me. And I don't need it connected to anything. Let me set my meter to my auto voltage just to drain any voltage off of these capacitors, if there's any. So that capacitor definitely had some voltage on it, 13, but you can see that this meter, because it has the auto voltage LOZ, not sure what LOZ stands for, load something maybe, but it's putting a load on this capacitor and therefore is draining it, which makes it safer for us to put our ESR meter on it. So it could take a while before this. The other thing some people do is just short the leads together to get the voltage out, but this is kind of the safer way to do it. And let me check this one too. I have to be honest, I usually don't do this. There's no voltage on that one, and doesn't look like there's any voltage on that one. So I previously checked these capacitors, and it's curious to know that, besides this one being a slightly larger capacitor, it checked out better than these, and it's holding voltage too. So yeah, so it might take a while for me to drain all that voltage out. Alright, so I'm not going to wait that long because I'm impatient, and it hasn't hurt me to do this yet before, but we will turn on our ESR meter. Let's see if you guys can see that. It's probably a little bit difficult to see, but we're going to hook up our, it doesn't matter if it's black. You can test, with ESR, you can test capacitors in circuit. If we were going to test the capacitance of these capacitors, we would have to make sure they were, in most cases you want to take them out of circuit to test that, and there is on these BM235, let's see, right there or whatever, but there is a capacitance tester on this as well. So, but we're testing ESR, something electronic series resistance or electrical, I don't know, something series resistance or whatever. So let's see if you can see that. So that is testing, it gives you a little reference voltage there. It says reference for 25 volt cap, good if capacitance is less than 470 microfarads. And this is a 470 microfarad 35 volt cap. And my cheat sheet says that that should be no higher than 1 on that one cheat sheet, and or on a different cheat sheet, because it really depends on the manufacturer, I guess, of the specs of the capacitor itself. But I just use a couple references. My other cheat sheet says it should be no higher than 0.24, I think. So it's getting kind of close to the range of where you would think it would be good. So, still probably okay, but close enough where you might want to replace it. Let's see about this one here. That one there is, it says reference good for if it's less than 330 microfarads, so 0.234 ESR. So this one is testing out of spec, basically. It's not that it's the capacitor shorted or anything, but it's testing out of spec. And let me see if I can, now we might get a spark when we connect these. Hopefully I don't blow up my meter. Yeah, see, you got a little, saw that little spark there. There was still voltage on that. Now this meter is testing 0.05, says reference 25 volt. This is a good cap with low ESR. 0.05 for 4700. My cheat sheet says that should be less than, it should be around 0.05 actually for my reference chart. And yeah, so anyway, so that's probably a good capacitor. There's a little reference chart here as well on the bottom here. It says 0.0. Again, this is just typical values. So for this meter itself, it has a cheat sheet that says 4700 for a 25 volt cap should be 0.12. So again, it's not, I don't think it's anything exact. It's not shorted, but it is does have low ESR. So that's testing the cap. So we're going to actually replace these two caps here and replace the battery as well. Do the battery mod from a Bob Roberts kit that I had. So let me do that. Actually, before I do all that, actually I want to put everything back in the game. I mentioned that before because I actually want to find out what's causing the hum or if we fixed it already. So hope this helped you guys. Drinking too early in the day so far to drink any beer. Maybe some people will say it's never too early, but I am enjoying some sweet tea in my Brofest cup. So cheers.